Last class we started working with the distributive property, and we kind of wrote out these just general steps for solving so that we would know exactly when things are supposed to happen. And we're going to refer back to and we're going to keep using these steps today, but we're not going to distribute. We are going to, this is the one I said was coming, we're going to get all the variables on one side first. Okay, so just on the next page, we're going to do variables on both sides. And we'll start with just a clean example. -5 plus p equals 7p plus 7. Okay, so if we go back through our steps that we talked about, 1 was distribute. There aren't any parentheses, there's no need to distribute. 2 was combining like terms on each side. And so here's where I think drawing that line is going to be especially helpful. Some of you guys have been doing it, some of you aren't. It's totally up to you, but that really helps to separate into, okay, over here, are there anything that can be combined? Well, no, because one has a p and the other one doesn't. Then if I look at the other side, can those be combined? Well, again, no, because this one's got a p and this one doesn't. So we're done with that step. There's no combining like terms we can do. And so here's where that third step comes in, is gather all the variables onto the same side. So I have this 1p on the left and 7p on the right. And one thing that can be helpful is if you think about move the lightest one. Okay, move the lightest term. Which one would be easier to pick up? Well, 1 would weigh less than 7, so that's the one we're going to move. Since I'm taking it away from this side, we're going to subtract the 1p minus 1p, and that leaves me 6p. The plus 7 comes straight down. This is still equals, and this -5 just comes down. Okay. Well, we got all the variables on the same side. Now we're ready to solve, and we're just going to follow the same steps that we always do. P is what we're trying to isolate, so we're going to subtract 7 first. I did it over here, so I have to do it on the other side. When we do that, 7 minus 7 is 0. 6p comes through, equals -5, and -7 is -12. Still trying to get p isolated, divide by 6, right? And then some of us are writing the actual division. Divided by 6, so that p equals -12 divided by 6 is -2. Okay. So before moving on, especially if you're not really sure, we want to check. Is p equals -2 a solution? So we're going to come back. -5 plus p equals 7p plus 7. -5 plus, we're going to put that -2 in for p, equals 7. Again, put the -2 in for p, plus 7. Well, when we clean up and simplify that, -5 plus -2 is -7. And then 7 times -2 is -14, plus 7 is -7. So we end up with this phrase right here, -7 equals -7. That tells me yes, right? That's a true statement. P equals -2 is a solution. Okay, we're not going to show the checking every single time, but this is what that question means to do, and this is, you know, what we're what I'm saying. When you ask me, hey miss, is this right? Did you check it? This is how you check it. Okay. Number 2. Negative n plus 7 is greater than or equal to 1 plus 6n minus 1. Okay. We've got our problem written and ready to go. So again, if I go back to the steps, there's no distribution. So we're going to combine like terms on each side. If I draw my line through here, look at the left, there's no like terms. When I look at the right, there's the 6n in the middle, but if I cover that up, it's got 1 and negative 1, and when I put those together, I'm going to get 0. So we can write 6n plus 0, or you can just leave that off. It doesn't, you don't have to show the plus 0, but if it's going to help you to have that there, you can. Nothing changed over here, negative n plus 7. This symbol is still the same. We haven't done anything to warrant moving it over. Okay. Now, I've got n's on both sides. Which one would be easier to move? Well, this one weighs negative 1, right? Remember, there's that 1 right there. It's going to be the easier one to move, so we're going to move that one. Use the opposite operation. Negative 1 plus 1 is 0. 7 comes straight down. The symbol stays the same. 6 plus 1 is 7n. Okay. Still trying to get that in isolated. So we're going to divide off the 7. Divide by 7. N, and 7 divided by 7 is 1. Now be careful here. I'm seeing lots of equal signs show up, or not paying attention to which side things are on. This should stay exactly the same. We didn't multiply by a negative, so it goes right like it did. I have this sitting here, and we need to be thinking, right, thought bubble, n has to be less or equal to 1, right? It's what it says about n. And this is where the organization is really important, because I'm seeing some people come over and just write it down. If you want to turn it around, then when you write n and 1, you've got to keep, like, the small side is with the n, we have to flip that around. These say the same thing. Okay? Always be thinking about what does it say about the variable. And then I'll use that to draw my number line. 1, that's the one we mark. It can equal it, so we fill that in. And the lesser numbers are back this way. 0, 2's out here. I want everything that's 1 and under. Okay. 3. I had a few of you kind of panicking when you start to see decimals or fractions, so we're going to do a couple that have those in there, just because I want to reiterate it's exactly the same process. So negative 2.1x plus 3 equals negative 0.108 plus 2.6x minus 4x. Okay. We're going to do the exact same process. We're going to follow the exact same steps. The only thing that's going to be different is now maybe the numbers are a little stickier and we can't do this in our head. Okay? So now is a great time to pick up your calculator if you need it, which is totally okay. All right? We're going to draw our divider because it's really messy. Anything to make it easier to look at will be helpful. And we're going to look at each side. no like terms on this side. I've got 2 that have x's on them. And if I just look at what's there, that says 2.6 minus 4, or 2.6x and negative 4. So 2.6 minus 4, this makes negative 1.4x. Okay. And leave everything else the same. That's still an equal sign, that's still 3, negative 2.1x. Okay. We got like terms combined, we're down to where there's an x on each side. Okay. And if you're not real sure, you know, we've talked a lot about how the bigger looking the negative number is, the further down it is, so that makes this one lighter. It's actually the lesser value. But if it just makes you more comfortable to move everything to the left-hand side, that's fine too. We can just go ahead, plus 1.4x, plus 1.4x. Okay, that leaves the negative 0.108. Keep the equal sign, plus 3, and then just make sure you're careful with your signs. Negative 2.1 plus 1.4. Okay, this is negative 0.7, negative 0.7x. So it doesn't change any of the steps that we're doing. It doesn't make it any new or different. It doesn't, we don't do anything special. Everything still follows the same order. So I'm still trying to get x by itself. We're going to use the opposite and subtract 3, minus 3. That goes to 0, negative 0.7x equals, and again, say this out loud, or at least think what it would sound like out loud in your head. It's negative 0.108 minus 3. So negative 0.108 minus 3. What we don't want to happen is negative 0.108 minus the negative 3, right? Because you wouldn't have said those 2 steps together. But it makes a really big difference in your answer now. That we have talked about negative 0.108 plus negative 3, right? If you read this negative 0.108 and negative 3, then that's totally okay. That's going to give us the same correct value that we want to work with. Okay, so negative 3.108. Still working on getting that x isolated. So we're going to divide by the negative 0.7. Divide by negative 0.7. That leaves x equal to, now you don't have to retype this. If you just hit divided by, it's going to take your answer divided by negative 0.7, and we get 4.44. And just, you know, go back and double check. It was negative, negative. That should give me a positive 4.44. Okay, same process. It's a little messier. You have to be really careful about copying numbers correctly when you work with them, but it's not so big a deal that you can't handle it. Okay, one more and then we'll be finished till class time. Number 4, this one's got fractions. Negative 7 over 15 plus 3 over 2n greater than or equal to n plus 1/3. Okay. As long as you're neat and careful, this is gonna be fine. Okay, I check each side. There are no like terms to combine. So now we're gonna try to put them together. I do need to think about 3 halves, and if you've got your calculator out because the one we just did was decimals, or you're going to grab that anyway, I can do 3 divided by 2 and that's 1.5. I could change that to a decimal and just use 1.5. But if I come out here, 1 divided by 3, this, remember we talked about, is not an exact value. And if I use an estimate and just put a 0.33 there, I am not going to get a very accurate answer. It'll be close, but it's not going to be completely accurate. So we want to just leave stuff as fractions. Now that I know that this is 1.5 and this is just 1, we're going to move, take away the negative 1 in, minus 1 in, and that leaves negative 7 over 15 plus, when you put this in your calculator, right, alpha y equals, enter 3 over 2 minus 1. It gives us that 1/2 back. I could have seen that it was going to be 0.5, but let's leave it in fraction form. 1/2 n. And all that's left over here is the 1/3. Okay. So let's start isolating the n. This is negative. Opposite operation, we're going to add 7/15 plus 7 over 15. Doesn't matter, it's positive, negative, it's a zero pair, plus 7 over 15. That leaves 1/2 n. This is still what it was. And again, we just go back, alpha y equals, enter, 1 over 3, plus alpha y equals again 7/15. And when we hit enter, it simplifies your fraction for you right away, 4/5. Okay. Now, because our calculator can keep track of fractions for us, I can still do exactly what we've been doing and just divide by 1/2. Okay, it's going to understand what we meant. 4/5 divided by 1/2. Okay, and it's going to give us our answer as a fraction. It's going to say 8/5. Now, you may remember from when you first learned fractions that if you do 4/5 divided by 1/2, that's the same thing as flipping, right? We use the reciprocal and multiplying. So we would do 4/5 times 2 over 1. There's that same 8/5 that we got from the calculator. Okay, either way is fine. You have access to this tool, feel free to use it, seriously. But if you remember that and want to do it this way too, that's totally okay as well. The number we divided by was not negative, so we leave the symbol the same. And this says that n should be greater or equal to 8/5. Okay, great. What does that mean? Well, I can make my number line and just put 8/5 there. Do my circle, fill it in. Greater than is this way. Okay? But it's kind of uncomfortable. Like, we want to know what number that is. So another approach, and something that'll make it a little bit more clear, especially when you're trying to decide, could, you know, x equal 2, or n, sorry, could n equal 2? Right? Maybe that's a solution. I need to know what 8/5 is. So instead of doing it as a fraction, we're going to do 8 divided by 5, and that's 1.6. So now I know my number line, right, at 1.6 is where this is equal, and it's increasing from there. So yes, n could be 2. Right? Two different versions of the same exact thing, just one of them is more useful in a different situation. All right? Okay, you're going to bring these examples with you to class. We're going to practice these for a little over a whole class period, lots of time. As long as you've got this with you, you'll be ready to go. Any questions that you had while we were going through these, make sure and have those ready to go so that we can clear those up before you get too far in.